All right, this is the last lesson in Chapter 8, lesson 8.6, Law of Cosines. In this lesson, we're going to look at another way to solve for missing side lengths or angle measures of a triangle that's not a right triangle. So, first thing, if you know the measures of two side lengths and the measure of the included angle, like side angle side, or all three side lengths, side, 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 then you can find all the other measures of the triangle by using the law of cosines. Now, remember back to law of sines, the key part you had to have was an angle measure and you had to know the side across. In these two, you will not have an angle measure and the side across. So, each one of these is three different equations to find either side A or angle A, side B or angle B, or side C or angle C. In each one of these situations, you're either going to be looking for, like I've kind of said, you're going to be looking for an angle measure or the side across from that angle measure. Okay, or you're going to be, and so each one of these equations is the same, but you're just using different information based on the sides given. So I don't want you to focus too much on memorizing the letters A, B, and C here, but understanding that the side length on the is always on the outside squared, equal to the cosine of the angle that it's across from. So if we were looking for angle C, we would be using side C on the outside, and then the other two sides are going to be the ones that are squared in here. If we're looking for A, then we're going to take the other two sides, which would be B and C, square them, minus 2BC cosine of A. Now this all cannot be separated. You cannot subtract this from this because these are attached to the cosine A. I'll explain a little more of that in a second. So let's look here at how this example works. Okay, the first one is labeled A, B, and C. So as we look at this, okay, we're looking for side B to the nearest tenth. Well, we start off here with a 44-degree angle. We don't have the side across. We're looking for it. We don't have it. So therefore, we cannot use law of sines. So what we do is we start with take the side length that we're looking for, and we're going to put it outside, and it's B squared. Then we're going to take the other two sides, and we're going to square them, 10 and 22. So we're going to get 10 squared plus 22 squared minus 2 times the product of these two, which is going to be 10 times 22 times the cosine of the angle across from the side we're looking for, which is going to be 44. Now, this problem can be worked a couple ways. I'm going to work it out all by hand here and then calculate the end, and then I'm going to show you how to work it all in your calculator. So we're going to bring down the B squared. 10 squared is going to give us 100. 22 squared is going to give us, let's see here, 484. And then we have 2 times 10 times 22, which is going to be 220 times 2, which is going to be 440. Cosine 44. Now, you cannot subtract 484, 100 minus the 440 because 440 is attached to the cosine 44. So this gives us 584 minus 440 cosine 44 equal to B squared. Now, so what we're going to do is we're going to calculate this, and what you can tell is because we're looking for B, not B squared, you're going to have to take the square root of this answer. So B will be the square root of this answer here. So let's take our calculator. Okay, and we're going to put it in as it says, 584 minus 440 cosine 44. Now that gives us this answer, and then we're going to take the square root of that, so I'll do the square root of this answer here. So I'll bring up my previous answer by hitting second and answer button. That gives me 16.35. So it says to the nearest tenth is going to be 16.4. So B is approximately 16.4. Now, you could also have done this whole problem inside your calculator, because anytime you're looking for the side length, you can do everything all at one time. So I'm going to hit the square root. Now I'm going to take 10 squared plus 22 squared. Now be careful as you're doing this, whatever calculator you're working on. So you want to be careful that you don't hit the right button and get outside the radical, because always make sure that your radical is continuing on. So next we're going to subtract minus 2 times 10. You can use the times button as well. Times 10 times 22. And then we're going to hit cosine of 44. Hit enter, and we get the same answer as 16.35, which is 16.4. So I know many of you guys like to put everything in your calculator. You can do this, but I would encourage you to make sure you write everything out and set it up so that you know if you missed something, you can go back and see what you missed. Now you can always work it out to this point and then put it in your calculator, which is just fine. Okay, so now let's take a look at our next problem. So you practice doing this. Find the length of mn to the nearest tenth. Now notice here we don't have a, b, and c. This is the reason why I don't want you to focus on the sides being a, b, and c. It's always going to be the side across from the angle that we're given. Okay? So since we're looking for this length here, we're going to call this side L. You can call it whatever you want. You can call it X, but I'll call this side L. I'll do a script L so it doesn't look like a 1. So we got L squared equal to the sum of these two sides squared. So you guys finish this problem off, come back and check to see how you do. Okay, let's see how you did. So as we finish setting this up, it's the sum of the two other sides squared minus 2 times the product of those two sides times the cosine of the angle across from the side we're looking for. So I went ahead and squared these and added them together to get 3,145. And I did 2 times 48 times 29 to get 2784 times the cosine of 104. Take the square root of everything, and that gives us our answer of 61.8. All right, so now let's take a look at how we find an angle measure. So we looked at how we find a side length. Let's look to see what we do for an angle measure. So in this problem here, triangle QFA. QF is 9, FA is 5, and QA is 8. Find the measure of angle F to the nearest tenth of a degree. So once again, I'll repeat myself a lot. The first thing you need to do is draw the picture. Draw your triangle so you know what sides are across from what angles. Now we're looking for measure of angle F. So which sides would it be across from? Well, the way you can determine that is which one does not have an F in it. This has QF, this has FA, and QA. That means that 8 is going to be across from angle F. Show you how that works. So we have Q, F, and A. QF, the distance is 9. FA, the distance is 5. And QA, the distance is 8. So angle F is across from 8. So now as we set this up, we're going to take the side that is across from the angle we're looking for. Okay, so we're looking for angle F. That means the side 8. So this 8 goes on the outside. 8 squared equals the other two sides squared. 5 squared plus 9 squared minus 2 times 5 times 9, that whatever you squared over here, you're going to put right here, times the cosine of, this is going to be angle F. Now, when you're doing an angle, when you're finding an angle measure, you can't put it all in at once. So what you have to do is you have to work out everything individually. So there's a long process, so let's just take a look here. So we know 8 squared is 64. Now if I was to square 25, or square 5 to get 25, 9 to get 81, add them together, that gives me a total of 106. Now multiply these together, so 2 times 5 is 10, 10 times 9 is 90, cosine F. So now, we cannot subtract 106 minus 90 cosine F because this is attached to it. Similar to the problem if I wrote out 106 minus 90x. We know we can't combine those two because this doesn't have an x. Well, this doesn't have a cosine F, so therefore we can't subtract them. So we're going to have to bring this number over here. So we do that by subtracting 106 to the other side. Now notice as you do this, you're going to get a negative result. So 64 minus 106 is going to be a negative 42, equal to a negative 90 cosine f. Okay, so just to make sure you're following along with me, and this is probably the way that you will work it as you're working these problems out, you'll start by doing 64 minus the 106. That gives us a real result of 42. So we write this down. Now we're going to divide by a negative 90. So to get rid of this, we divide both sides by a negative 90. Okay, so I go back to my calculator. I'm going to get this answer here. So I'm going to say divided by negative 90. Make sure you put the negative in there because this sign is also negative up here, which gives us this decimal. Now I'm not going to write this decimal down. I'm going to end up using it here in a second. So at this point, we're looking for an angle measure, which means once again we have to use our inverse function. So f is equal to the inverse cosine of this division problem. So that whatever we divided, negative 42 divided by negative 90, that result is what we're going to be dividing. So as we go back to our calculator, I can do, since this is my division problem, I can say second cosine, bring up my previous answer of the 0.4446 repeating, and that gives me the correct answer of 62.18. Now, it says to the nearest tenth of a degree, so our answer here is going to be 62.2. Now let me also tell you this. You can also take the inverse cosine and you can put in the negative 42 divided by the negative 90, and you put it in this way, and that's going to give you the same result, 62.2. Okay, so we can do the division earlier and then put it back in our problem, or we can do the inverse cosine of the division problem. So both answers, either way, is going to get us 62.2 degrees. All right, so let's take a look at another one. You guys work this one. This time we're looking for angle V, which means which side should be out to the opposite side, which one should be away by itself. It should be the one across from it, so the 4.4. So pause the video now and come back and see how you do. All right, so let's see how you did. We should have set this up as 4.4 squared equals the 6.7 squared plus 7.1 squared minus the 2 times 6.7 times 7.1, same numbers we squared added here, times the cosine of angle V. So as we square this number here, we get 19.36. These two squared and added together gives us 95.3. And the product of these three numbers is 95.14 times the cosine of V. So we have to bring this number over here by subtraction. Subtract this over here, we get a negative 75.94 equals a negative 95.14 cosine V. So now we're going to divide both sides by negative 95.14, and then we're going to do the inverse cosine of that fraction. As you put it in your calculator, you should get approximately 37.0 rounded to the nearest tenth. All right, so now we've found the measure of angle V, which we said was 37.0. Now, the next part, they ask us to find the measure of angle T. So you have some homework problems that ask you to find both angles, so that means we're going to use the law of cosines again. So now, because we're looking for angle T, you got to determine which side goes across from angle T, and that's the one that goes outside. And that's going to be the 7.1. So set up the next part, which is going to be right here where it said find the measure of angle T. Solve for angle T, round to the nearest tenth of a degree. Pause the video and then come back and see how you did. All right, let's check your work. So we're looking for angle T, which means we're going to use the side 7.1 over here by itself. So 7.1 squared is going to be 50.41. We take 4.4 and 6.7 square and both add them together to get 64.25. And then the product of 2 times 4.4 times 6.7 is going to be 58.96 times the cosine of t. So it becomes a minus because we're subtracting. Now we're going to bring the 64.25 to the other side by subtracting it, which leaves us with a negative 13.84. set it equal to a negative 58.96 cosine t. Divide by negative 58.96, and then we're going to do the inverse cosine of that to get our solution of 76.4 degrees. So this angle t is going to be 76.4. So if they ask us to find the third angle u, you would take 180 and you would subtract the sum of 76.4 plus 37.0. And if we add those together, 76.4 and 37 gives us 113.4. Now we're going to subtract that from 180. And that gives us a 66.6. So this would be 66.6 degrees. All right, so now let's take a look at a couple word problems. An air traffic controller is tracking a plane at 2.1 kilometers due south of the radar tower. A second plane is located 3.5 kilometers from the tower at a heading of north 75 degrees east. So this is kind of a vector reading. And so the way this is read, it means 75 degrees east of north. So we're going northeast in that northeast direction. And the way we read it is 75 degrees east of north. The first number is like the direction you're looking, and you're going to go towards the east, 75 degrees. To the nearest tenth of a kilometer, how far apart are the two planes? So my suggestion is to draw a compass rose, which is basically the same thing as an XY coordinate plane. So we'll draw our XY coordinate plane here. Okay. Now we know this is north, this is south, east, and west. So we have an air traffic control tower, and we're going to leave that here at the origin. This is the tower. Now, the first plane says it is 2.1 kilometers due south of the tower. So due south will become straight down here, 2.1 kilometers. So this distance is going to be 2.1. Now, the second tower, the second plane, so we'll call this plane 1. The second plane is going to be 3.5 kilometers at a heading of north 75 degrees east. So the way this looks is if I were to draw a line, I would go facing north first, and I'd go 75 degrees towards the east. So that's going to be somewhere like so. The 3.5, it doesn't matter really how far you draw it here. This distance is going to be the 3.5. So in this right here was our first plane going down to the south. So this right here would be plane 2. So the question says, how far apart are my two planes? So we want to know what this is our x. How far apart are these two? So let's take the information they've given us. Okay, this is 3.5. Okay, so the 75 degrees here is, if I drew this line here from the north, this is the 75 degrees it's referring to. 75 degrees from the north towards the east. If it said north 75 degrees west, we would start at the north and we'd go to the west. So the angle we need to know is we need to know this angle right here. Now because from north to south is a straight line, that means it's equal to 180 degrees. Because this goes into two different quadrants here, this becomes an obtuse angle, which means we need to find the measure of this angle right here. So to do that, we're going to take 180 minus 75 because these two form a linear pair. And 180 minus 75 is 105 degrees. So this angle right here is 105. Now you could have also found this by breaking this. We know this, each one of these is 90 degrees. From north to east is 90, from east to south is 90, from south to west is 90, and west to north is 90 degrees. So you could have done 90 minus 75 and put this is 15, added the 90 from this, and got 105. So we got 105, that's our angle here. Now we're looking for the side across, which means that this x is going to go over here by itself. We're going to use law of sines to solve. X squared is equal to 2.1 squared plus 3.5 squared minus 2 times 2.1 times 3.5 times the cosine of 105 degrees. So you can put this all in at once. You can calculate it out. So I'm going to do part of it. 2.1 squared plus 3.5 squared is going to give us 16.66. And then the product of these three are going to be 14.7. And then bring down the cosine of 105. Now, this point here, I'm going to take the square root of both sides, do the rest of my calculator. So I take the square root of 16.66 minus 14.7 cosine 105. Enter, and that gives us 4.5. So the distance between our two planes is approximately 4.5 kilometers. So that becomes our distance. So this distance is 3.5, this is 2.1, this distance here between is 4.5. All right, so let's go to the next problem. Same type of problem, we're dealing with these directions here, vector coordinates. Okay. You and a friend hike 1.4 miles due west from a campsite. At the same time, two other friends hike 1.9 miles at a heading of south 11 degrees west, or 11 degrees west of south. From the campsite to the nearest tenth of a mile, how far apart are the two groups? Now, my suggestion here, and kind of a hint, is let the campsite be at the origin. So as you set your picture up, draw your compass rose, put your campsite at the origin, and find the distance that the two campers or two groups are apart. So pause your video, do this now, and come back and see how you did. Okay, so as you draw this picture, we start the campsite here at the origin. The first group goes out to the west, 1.4 miles. The second group goes 11 degrees to the west of south. So if we face south first, and go 11 degrees towards the west, this is our 11 degrees. Now, this is 1.9 miles here as I drew. The 11 degrees is referring to this distance right in here, this how many angle measure here. Now, to get this angle here, this is a right angle. From west to south is a right angle. So therefore, it is 11 degrees less than 90, which means you do 90 minus 11 to get 79. So because we're looking for the distance apart for our two groups, this is our x, the angle across from it is 79. So we set it up as x squared equals 1.4 squared plus 1.9 squared minus 2 times 1.4 times 1.9 times the cosine of 79. So I combined it here to get 5.57 minus 5.32 cosine 79, square root both sides, and that leaves us with the distance the two groups are apart are 2.1 miles. So this is the last part we're going to do in lesson 8.6. So if you have any questions, go back and rewatch the video, look through the completed notes that I've also posted, and begin on your homework.